Today, we're going to be adding polynomials, so we're going to do the first 5 examples. Now, how is this different from what we did yesterday? Yeah, it's not. Not really. Adding 2 polynomials, well, addition doesn't care what order you do things in. So really, all the parentheses, so long as the thing in between them is addition, don't make a difference. We can, quite literally, rewrite each and every one of today's problems without the parentheses. So that's what I'm going to do. I'm going to do that so I can do all this work with the black pen and not have to constantly change it. And while I do that, you can listen to my dog decide he needs to growl at whatever is walking by out front of my house right now. Because clearly something has encroached upon his domain and he is not having it. So again, when we have addition in between parentheses, we can essentially act as though those parentheses don't even exist. They are completely superfluous, which is a big fancy word that means they don't matter in the slightest. So give me one moment to finish copying this last problem. Plus a squared minus 2 plus 1 plus 6. One thing I will point out in this last example, where I have the 3ab and I just wrote minus and not plus minus, it is because when plus and minus are right beside each other, the subtraction or the negative sign takes precedence. It overrides the plus. So, we can do exactly what we were doing yesterday at this point, which is identify our like terms and combine them. So our first problem has an 8x squared and no other x squareds. It has a negative 2x and a positive 9x. That combines to make 7x. We have a positive 3 and a negative 5, which combine to make negative 2. In our second problem, we have CD to the second power in our first piece, and we have another CD to the second power later on. So combined, that's negative 10 CD to the second power. Our next term is negative 2 CD. We have a positive 9 CD later on. Negative 2 plus 9 is positive 7 CD. And now he's barked so much that it's gone to the puppy bark. And then we have a plus 5 and a minus 5. And they actually cancel each other out. So I don't have a number part of my answer. Third example, we have AB to the second and a 2ab to the second, so that's 3ab to the second. Then we have a 3a, there's another 3a, and a 2a later on. Putting all of the a things together gets us 8a. And we also have a negative 2 and a positive 4 as plain numbers. Negative 2 plus 4 is positive 2. In the fourth example, we have a to the second power starting us off, 4a to the second power. That can combine with the 5a to the second power later on, making 9a to the second power. Then we have a 3a. That can join up with the 2a to make 5a. And as far as plain numbers go, we have a positive 1 and a positive 3. Together, that's positive 4. And in the long example, where everything in between the parentheses was a plus sign, so I could just get rid of the parentheses, we have 3a to the second, b to the second. I don't see anything else that has a to the second and b to the second in it. So that means that is part of our answer. Then I have 2a to the second. As I look through, I see one more a to the second further down, so that means we have plus 3a to the second as part of our answer. Then I have negative 5ab. I've got a negative 3ab and a positive 6ab further down. So I've got 3 things that are ABs. Negative 5 minus 3 is negative 8. Negative 8 plus 6 is negative 2 of those. And then we need another color because we still have some things not underlined. The negative 2 and the positive 1. Negative 2 plus 1 combines to be a negative 1. And we have our final simplified version of 3a squared b squared plus 3a squared minus 2ab minus 1.